Hello and welcome. We are going to look at multiplying numbers that are written in scientific notation. So as we look at this example, just some things that we want to remember before we get started is scientific notation is going to be this number that is written and has two factors that are multiplied together. And this first number has to be between 1 and less than 10. Okay, so it's got to be greater than 1 and it's got to be less than 10. And then the second factor over here is going to be the number 10. And that's going to show you that this is written in scientific notation. Another thing that we want to remember is the associative property of multiplication, which says that you can actually group this problem in any way. You can group these factors in any way, and it's still going to give you the same result. So with this question, we want to multiply, and our final answer, we want to write that answer in scientific notation. So I'm going to rewrite this over here, just as we have it with the question. But then what I want to do is I want to look at using the associative property of multiplication to kind of rearrange this to make it easier to multiply. So what I'm going to do is I'm going to take this number and I'm going to group it with this one. So then I would have 3 times 3. And then I'm going to keep this times 10 to the 4th. And then when I multiply 3 times 3, I would get an answer of 9. And then I would just keep this as is 10 to the 4th power. And when you get your final answer, the important thing to do is to check to make sure that this number here is going to be, it's got to be less than 10. So we know that 9 is less than 10. And it's got to be greater than 1. Okay, and so as long as that works, and as long as you follow the steps, then we can say that this is going to be our final answer. So 9 times 10 to the 4th power. Let's look at another one that's similar to this one. So this question, very similar, but now we kind of have some choices that we get to choose from. Okay, same thing applies with this one, is we want to make sure that our final answer is written in scientific notation. And we can use the associative property of multiplication to regroup those factors to multiply. So 2 times 4 to the 10 to the 2nd power. And then I'm going to regroup these and I'm going to say 2 times 4. And then I'm going to leave this as times 10 to the 2nd power. 2 times 4 will give us 8. And then 8 times 10 to the 2nd power. So we would say that our answer is going to be this one right here. We do want to also make sure, double check, make sure that this number is greater than 1, but has to be less than 10 in order for it to be written in scientific notation. Look at another example of this. So this one, we're going to write it the same way. 5 times 8 times 10 squared. I'm going to regroup these. I'm going to take the 5 and the 8 and group those together. And then I'm going to keep this as times 10 to the 2nd power. And then 5 times 8 would give us 40 times 10 to the 2nd power. When I check this, I can see that 40 is not going to be less than 10. So it is not less than 10. And so I have to change something with this question in order to make it to where it is written in scientific notation. So one thing to remember is even with this whole number, we do have this decimal that is sitting right here. And so what I want to do is I want to take this decimal and I want to move it where it would work. The number would be greater than 1, less than 10. So I'm just going to move it over one place so that it's between the 4 and the 0. But since I moved it over one place, I have to take this exponent and I have to increase it by 1 because I moved the decimal one place. So my new answer would be 4 times 10 to the third power. Remember with scientific notation that this times 10 squared is actually telling you you would move the decimal over and you'd have a larger number because the exponent is positive. And so in this case, we would just be increasing the final answer. If we wrote this in standard form, we could write move the decimal over an additional place, and that would be equal to this answer of 4 times 10 to the third. So our final answer is 4 times 10 to the third power. And that's where it's also important. Make sure you check at the end. Make sure that you just kind of look at that final answer that you got. Make sure that it is greater than 1 and less than 10 for this first number. So this one's going to look a little bit similar, but different numbers we are working with. So we've got 8. These numbers are the same, 8 times 5, but then we have 10 to the first power. And so you can kind of see that this one is going to be one that it's important to check that final answer that you get. We're going to regroup this with 8 and 5. So 8 times 5. And then we're going to multiply this by 10 to the first power. 8 times 5 is 40 times 10 to the first power. But we have to remember it has to be, this number here has to be greater than 1, but less than 10. So I'm going to take this decimal that I have here and I'm going to move it over one place to be between the 4 and the 0. But then I'm going to take this exponent and I'm going to add 1. So that's going to give me my answer of 4 times 10 to the second power. Now, if you had like 400 and you had to move the decimal over 2 places, that's where you would add 2 to this exponent. So it really depends on how many places you have to move it over in order to make this first number written correctly so that it is in scientific notation. All right. So looking at this next question, now we have a decimal. So scientific notation we can use for very small numbers as well, but remember that also means that you're going to have a negative exponent. So, and this number is actually, this 5 is correct, but if we were to multiply this, we're going to say 0.04 times 5 times 10 to the 0 power. And then I'm going to regroup this as 0.04 times 5. And then this is going to be times 10 to the 0 power. When I multiply 0.04 times 5, I'm going to get 0.2 times 10 to the 0 power. But I do have to remember that this also applies to those rules where this first number has to be somewhere between 1 and 10. It has to be greater than 1, but less than 10. And so 0.2 is actually less than 1. And so we need to look at this and we need to actually take this decimal and move it the other direction. So now we're going to be moving it to the right. So since we moved this, we're actually going to be subtracting 1 from this exponent. Since we only moved one place to the right, we're going to subtract 1, which is going to give us an answer of 2 times 10 to the negative first power. Okay. All right. Looking at another example of this, we've got 0.4, and we're multiplying this by 1 times 10 to the 0 power. And we're going to regroup this using the associative property of multiplication. So we're going to say 0.4 times 1, and then we're going to leave this as times 10 to the 0 power. And this is just going to give us 0.4 times 1 is 0.4. And so we would be left with this. And then we have to make sure that we look at this first number has to be greater than 1, but less than 10. And so we would say, we got to take this decimal and we got to move it over. And since we're going to the right, we're actually going to subtract 1 from this exponent. And so this would give us 4 times 10 to the negative first power. Right here. Only a couple more examples. So this is where we're going to be looking at multiplying 2 numbers that are written in scientific notation. So we've got 3 times 10 to the 10th power. This number is written in scientific notation. And then we're also multiplying it by 2 times 10 to the 9th power. Okay. So you can still group this. But this time what we're going to do is we're going to group these numbers together. And then we're going to group the powers of 10 together. So we're going to group these together. So what it's going to look like is it's going to look like we've got 3 times 2. And then we've got 10 to the 10th power times 10 to the 9th power. So when we multiply, we're going to multiply these first factors together, just like we would in those last examples. So 3 times 2 is 6, times his factor of 10 is going to stay, but now we have to remember those rules with exponents. And so when the base is the same, that's where you're going to add those exponents together. So we would just take this, say 10 plus 9, and that would leave us with an answer of 6 times 10, and then our exponent would be to the 19th power. So we have to make sure that we follow those rules, incorporate those rules with exponents into solving this where we're multiplying numbers that are written in scientific notation. All right. So the next example, and this was the last one. So we've got 6 times 10 to the 5th power. And then we've got 5 times 10 to the 2nd power. So we're going to regroup these just like we did the last one, where we're going to group these factors together. And then we're going to group the powers of 10 together. So what it's going to look like is it's going to look like 6 times 5. And then we would have 10 to the 5th power times 10 to the 2nd power. So then 6 times 5 is going to give us 30. And then times 10 to the, it would be 5. And then since the bases are the same, our exponents, we're going to take these exponents, add them together. So we're going to say 5 plus 2. And that's going to give us an answer of 30 times 10 to the 7th power. But that's where we have to look at this first number. We have to say, this number is larger than 10. We need that number to be greater than 1 and less than 10. And so what we need to do is we need to take our decimal that is here, and we need to take this decimal and we need to just, we're going to just end up moving it over one place, put it between the 3 and the 0. Since we moved it to the left, this is where we're going to add 1. Moved it over one place, so we're going to add 1 to our exponent. So if you move it to the right, you're going to subtract. If you move it to the left, you're going to add with scientific notation. So that's going to give us our answer of 3 times 10 to the 8th power, which would be this one right here.